So we can take the trig functions of any angle on the coordinate plane. If we take a look at the quadrants, quadrant 1, we have all three of our original trig functions are positive. In quadrant 2, sine is the only one that's positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. Remember that the sine of the angle is the same as the y value on the unit circle. The cosine of theta is equal to the x value, and the tangent of theta is the same as the y over the x. Okay, so now let's take a look at example number 1. We're going to let the point 7, -4 be a point on the terminal side of our angle. And so if we're looking at the coordinate plane, if 7, -4 is on the terminal side, then we know that this point is going to be somewhere along that terminal side. And so we can make a right triangle out of that. Because remember, no matter how large that triangle is, the ratio of the sides is going to remain the same because our angle isn't changing. And so we have the point 7, -4, which means that this side is 7 and this side is -4. Okay, so we want to find the sine, cosine, and tangent. Well, in order to find the sine, we need to take the opposite of this angle, the opposite side, and the hypotenuse. Well, we don't know the hypotenuse yet, so let's find that. Okay, so x squared plus y squared is equal to r squared, which is the radius if we're looking at the unit circle. And so that means that 7 squared plus -4 quantity squared is going to equal r squared, or the hypotenuse squared. So then 49 plus 16 equals r squared. So then 65 equals r squared. So r is the square root of 65. And we cannot simplify that because 65 only breaks up into 5 and 13, and both of those are prime, not perfect squares. Okay, so now we have all of our values, and so we can find the sine of our angle. And so when we look at this angle here, our opposite side is -4, and the hypotenuse is the square root of 65. Remember, we just found that. And we can label that up here if we need to, if that helps. Now remember that we cannot leave a radical in the denominator, so we need to rationalize. So we're going to multiply by the square root of 65 in the denominator. Remember, whatever we do in the denominator, we have to do to the numerator. And so that leaves us with -4 square root of 65 in the numerator. And then when you multiply the square root of 65 times the square root of 65, you're left with 65. So that is our sine value. Now let's take a look at the cosine value. Remember that cosine is the adjacent, which is 7, over the hypotenuse, so square root of 65. And again, just like in the sine, we can't have a radical in the denominator. So we're going to multiply the denominator and the numerator by the square root of 65, because essentially that's really just multiplying by 1. So we have 7 square root of 65 over 65. All right, and then the final part of this problem is to find the tangent of theta. Now remember that tangent is opposite over adjacent, so the opposite side is -4 and the adjacent side is 7, and so that one doesn't even need to be simplified. All right, so whenever we have angles that are not in quadrant 1, we need to use what we call reference angles. And so we're going to use reference angles, and those are created by drawing a vertical line from the terminal side to the x-axis. Okay, and so in quadrant 2, we can find that by subtracting the angle measure from either pi or 180 degrees, depending on which unit of measurement you're using. In quadrant 3, you're going to take your angle and subtract either pi or 180 from it in order to get that reference angle. And then in quadrant 4, you're going to subtract the whole circle, whether it's 2 pi or 360, minus the angle that you are trying to use. All right, so let's take a look at example 2, part A. We have the sine of 11 pi over 6. And so we need to figure out what would that reference angle look like, okay? And so we know that 11 pi over 6 is going to land in the 4th quadrant. So this angle here is 11 pi over 6, which means that reference angle is going to be pi over 6. Okay, because then that will make it a full circle. So 2 pi minus 11 pi over 6 is the same thing as saying 12 pi over 6 minus 11 pi over 6. And so that's where our pi over 6 as the reference angle comes from. Okay, and so now we can take the sine of 11 pi over 6, and we can say, well, that's going to be the same thing as the sine of negative 11, no. And we can say that that's going to be the same thing as the sine of negative pi over 6. And if we think about our odd and even functions, sine is odd, so that's going to be the same thing as negative sine of pi over 6. And so if we remember on our unit circle, when we have pi over 6, we have square root of 3 over 2 as our x value, and then 1/2 is our y value, but because we're in quadrant 4, that's going to be negative, okay? So remember that sine of pi over 6 is 1/2, and then again, it's going to be negative because we're in quadrant 4. All right, let's take a look at the cosine of negative 60. All right. So we can look and see what quadrant we're in. We're going to be in quadrant 4 because our rotation is going clockwise. And so our reference angle is 60 degrees. And so our cosine of negative 60 degrees is going to equal the same thing as the cosine of 60 degrees because remember, this function is even. Okay, and so when we find the cosine of 60 degrees, so then we can look at our unit circle and we see that at negative 60, we get 1/2 negative square root of 3 over 2. And so the cosine value is going to be 1/2. All right, and then finally, let's take a look at part C, where we are finding the tangent of 17 pi over 6. And so if we subtract a full circle from 17 pi over 6, that's going to be 12 pi over 6. So then when we subtract that, we get 5 pi over 6. And so that is going to land in the 2nd quadrant. And so here is our 5 pi over 6, which means that our reference angle is going to be pi over 6, okay, because pi minus 5 pi over 6, pi minus 5 pi over 6 is going to give us pi over 6. Okay, so then we can take a look at, well, we know that the side opposite pi over 6, that's our y value, is going to be 1/2 because it's the smaller side. And then the x value's got to be the square root of 3 over 2. But because we're in the 2nd quadrant, it's going to be negative. Okay, so we want to find the tangent of 17 pi over 6. And that's going to be the same thing as the tangent of 5 pi over 6. And so remember that tangent is y over x, so 1 over negative square root of 3, because remember, if they both are being divided by 2, the 2's will just cancel. But then we need to rationalize our denominator. So we multiply the denominator and the numerator by square root of 3. And so we're left with negative square root of 3 all over 3.